Bismillahirrahmanirrahim. Today we are going to start topic 2.3 scalars and vectors. So first of all you have to know about what are the scalar quantities. Previously we have learned about physical quantities. Now we will see among all physical quantities which quantities are called scalar quantities. Physical quantities can be divided into scalars and vectors. A scalar quantity is described completely by its magnitude only. Let's take the example. Here you have mass of 10 kg. If mass of object is 10 kg, then 10 is numerical value and kg is unit of mass. So we can say the magnitude of a quantity means its numerical value with an appropriate unit. Here you can see this boy is talking about the time that it takes 40 seconds to switch off light. Means 40 is numerical value and second is appropriate unit of time. We can say time is scalar as mass. Other examples of scalars are mass, length, length means distance, time, speed, volume, work and energy. Now we will see what are the vector quantities. A vector quantity is described completely by magnitude and direction. Let's take an example. If you want to invite your friend at your home, you have to tell him distance as well as the direction to locate your home from the reference point easily. So we can say distance of a place from reference point is insufficient to locate the place, as we have learned earlier that distance is a scalar quantity. The direction of that place from reference point is also necessary to locate it. So, if you tell him in that way that 30 meter is the distance towards east, then it will be more convenient for your friend to locate your home from that particular place that is called reference point. So, you can say distance 30 meter is distance plus direction is equal to displacement. Means whenever scalar quantity is described by its direction, then it termed as vector quantity. So displacement is a vector quantity. Other examples for vectors are velocity, displacement and force. Now referring to exercise question 2.3 part 6, difference between scalars and vectors. So here are some differences between scalar quantities and vector quantities. First point, scalars completely described by magnitude and units. Vector quantities completely described by magnitude, units and direction. Second point, simple letters are used to represent scalar quantities such as simple T stands for time and M stand for mass. For vectors, we generally use bold letter to represent them such as bold F stand for force and bold D stand for displacement, or a bar or arrow over their symbols. Third point, any change in scalar quantity is reflection of change in only magnitude because scalar quantity completely described by their magnitude. Any change in vector quantity is reflection of either change in magnitude or change in direction or changes in both. Arithmetic addition is possible for scalars. Arithmetic addition means ordinary operation of mathematics. For vectors, arithmetic addition is not possible. They are added by head to tail rule means vector algebra. Examples of scalars are mass, distance and time, and examples of vectors are displacement, velocity and force. Now we will see how vector quantities can be represented. So here is graphical representation of vector. I am also referring exercise question 2.10, how vector quantities can be represented graphically. So here are some steps to represent a vector graphically. Graphically, a vector can be represented by a line segment with an arrowhead. In this figure, this line AB, arrowhead at B point, represents the vector V. Look at this figure. Here is point A. This point A is the initial point of this vector called tail of vector. And Here is point B, the ending point of vector, where you can put the arrowhead called head of vector V. And this arrowhead also representing the direction of vector. Length of line AB gives the magnitude of vector. So you can see, if you are increasing the length of this vector, length of this line means you are increasing the magnitude of vector quantity. And this magnitude is represented on a selected scale. So what is the selected scale for a vector quantity? Scale of a vector means keeping its orientation, means direction same but changing its length by a scale factor to project it on a paper easily. In daily life, you can see vector quantities are like displacement, and displacement may be, it's a huge value. To represent it on a page or paper, you have to change the scale, or you can say change the factor of this displacement. So we can change this factor by using a suitable scale. Fourth point, while the direction of the line from A to B gives the direction of vector V. You can see here line A to B. This is also symbolizing the direction of vector. In what direction? Towards east, north or south. This head will symbolize this direction. We are going to solve example 2.1, represent a force of 80 Newton acting towards north of east. You know that force is a vector quantity. Here 80 Newton is magnitude of force and north of east is direction of force. Before going towards solution of this example, you have to know about this figure. What is this? This is called the geographical projection. Here N, S, E and W are written. N stand for north, S stand for south, E stand for east and W stand for west. Basically, this north-south, this vertical line shows north and south pole of Earth, and this horizontal line represents east and west direction of Earth. So, we have to project all the vectors according to this geographical projection. So, whenever we will draw the vertical line, basically we will symbolizing the north pole, and whenever we are going to draw this horizontal line, basically we are representing the east west direction. So first of all, we have to do step 1, draw two lines perpendicular to each other. Horizontal line represent east west direction. You know that lengthwise a line is called the horizontal line, and vertical line represent north south direction, means height wise line you will draw. This represents the north-south direction as shown in figure 2.15. So we have drawn here these lines. Step 2, you have to follow, select a suitable scale. Basically 80 Newton is very big value. You can't project this 80 Newton on this small paper. So first of all, you have to convert this large value to the convenient value, means you have to change this value according to scale. So if we take the scale as 1 centimeter on your meter rule, if this 1 centimeter represent the 20 Newton, then 4 centimeter will represent the 80 Newton. So we have converted this value. So step 3, you have to follow, draw a line according to the scale in the direction of the vector, as direction is north of east. This is the north direction and this is the east direction. So line will be in between of this north and east. So you have to draw this 4 centimeter line according to the direction north east. So in this case, draw a line OA. OA means from origin you have to draw this line of length 4 centimeter along northeast direction. Step 4, put an arrowhead at the end of the line, and this arrowhead will represent the direction of vector. In this case, arrowhead is at point A. Thus the line OA will represent a vector, the force of 80 Newton acting towards northeast.